We spend 1/3 of our lives sleeping, and still we don't know why we sleep. We know some functions, but overall it's still a mystery.
From the beginning of time, all living beings have been governed by the need for sleep.
Sleep is considered one of the critical, necessary components to life. If you don't sleep, if an animal doesn't sleep, it dies.
Yet for many modern-day humans, a good night's sleep has become elusive.
Being exposed to light, even at low levels, has an adverse effect on sleep. Even just the equivalent of a couple candles a meter away from you. You need to know how to switch off at night. And above all, never use a screen after 8 p.m.
And that's one of the reasons that has contributed to this epidemic of sleep deficiency that is in our society.
Today, lack of sleep affects all age groups.
Insomnia is very common. It's estimated that nearly 10% of adults around the world are severely insomniac.
In the space of 50 years, we've lost some 1.5 hours of sleep per night. Scientists around the world are racing to find solutions. But how do you recover sleep that's been lacking for so long? Anything's worth a try, from the most natural remedies to the most high-tech.
I don't face the night like I'm not going to sleep. I don't have that anymore. That's gone.
In just 2 generations, we've lost around 90 minutes of sleep each night. Today, the average European sleeps less than 7 hours a night. Worse still, 1 out of 3 18 to 35-year-olds gets fewer than 6 hours of rest a night. One reason is the omnipresence of blue light. It doesn't just bother us when the time comes to sleep, it also throws our everyday lives out of sync. Adolescents fall asleep later and later. Half of them suffer greatly from sleep deprivation or sleep debt.
Today, the per capita exposure to light is about 10 times more than it was 50 years ago. So lighting is ubiquitous, where we would have one lamp in the living room, and electricity was so expensive. I remember my father like, turn off the light, are you paying for this? And now it's so much cheaper to keep the lights on that the ceilings are covered with built-in lights. And when you switch on, you're being bathed in blue enriched light in many cases, and you're not tired. We share in common with many other species, plants, animals, insects, that the light-dark cycle is the most important synchronizer of our internal biological clock.
Professor Charles Czeisler is the father of modern chronobiology, the science of our body's internal rhythms. He's investigated the effects of natural and artificial light. Since the dawn of time, most living species have been downright bombarded with the white light emitted by the sun. White light is composed of a palette of colors. They range from red to violet, but the blue tones predominate.
LEDs could not make white light because no one knew how to make a blue LED. So when the scientists discovered how to make a blue LED, that has created an entire revolution.
Before then, we used incandescent light bulbs with heated filaments. These were replaced with energy-saving LEDs, and this is where the problem lies today. Since the advent of blue LEDs, each bulb in our homes emits the white light of a small sun. All our screens use this same technology. They flood us with blue light without us noticing it.
Now, the electric light to which we're exposed, in terms of resetting our internal clock, is like light on steroids. It's like got this tremendous peak in the blue part of the spectrum. It's telling the brain, oh my goodness, it's the middle of the daytime.
Our main biological clock is located in the brain, right behind the optic nerve. It is synchronized by sunlight and controls all our bodily rhythms. This clock is set to a 24-hour cycle, the time it takes the Earth to complete one rotation on its axis. So what happens if we are constantly exposed, day and night, to light that is not sunlight, but which the brain interprets as such?
As we have reduced the strength of the synchronizing effect of solar light and increased the disruptive effect of electric light, it has dispersed us because we don't think about, we turn on the lights to do things in the evening. After the sun sets, we turn on the light. We don't think about the fact that when we turn on the light, it is shifting our circadian rhythms to a later hour. So all of us on average, compared to where we would have been 200 years ago, we have shifted ourselves about 3 to 5 time zones westward. We've actually studied people here in Boston that are living in the same city, and their internal clocks are 12 hours apart. So, that's just sort of a mind-boggling finding. So one person's internal clock will be on Hawaiian time, and the other person's biological clock will be on Paris time, and they're both living in Boston. And then we wonder, why are we having trouble falling asleep at night?
This is precisely what Professor Claude Granfier is trying to understand. In his lab, he conducts isolation experiments to determine participants' photosensitivity.
Our experiment is designed to answer the question with a light intensity equal to what's in this room, so around 150 to 200 lux, or what you might have in your kitchen after sundown. How long does it take for this light to activate the brain?
To find the answer, Professor Granfier studies the effect of light on test subjects who spent 3 days in total isolation, with no temporal reference points and with no sleep for 34 hours.
I'll let you settle in. This is your room. I hope you were told to take off your watch. You're not wearing one?
No, I just have my phone, but I'll turn it off.
Okay, Loïc, we're going to close the door and start the experiment. We'll open it again on Thursday, okay? See ya.
Let me show you what we're looking at. We want to calculate the size of your pupils when they're exposed to light. Once the light starts to bother you, click this button. Various kinds of light activate different kinds of photoreceptors. The participant is subjected to this same lighting every 2 hours. This helps us determine if there are certain times of day when we're more affected by light than others.
Our results show that it takes between 2 and 5 minutes for light to activate the brain. The pupils constrict rapidly. The heart rate shoots up, as does the body temperature. So clearly, light activates many parts of the body.
Melatonin is the hormone that induces sleep. It's produced naturally in the brain and is particularly sensitive to light.
We've been able to show that even very low levels of light, between 1 and 2 lux, the equivalent of a couple of candles a meter away from you, can reduce melatonin secretion by 10%. So we've gone from thinking that very high levels of light were necessary to observing effects at very low levels. For instance, the light you're exposed to in bed in the evening emitting from a cell phone, tablet, or computer.
Incessant light pollution has an impact on society as a whole. Day and night, swarms of people work in shifts to meet growing production demands. There are 25 million shift workers in the United States alone. The consequences are dramatic.
Shift workers who continuously shift from daytime to nighttime, flight attendants who are flying continuously across time zones, they have an increased risk of cancer. People who sleep 5 hours a night or less have a 300% increased risk of calcification of the coronary arteries. We've shown that when resident physicians work extended duration shifts, they make significantly more serious medical errors. They stab themselves more often with needles or scalpels. The more senior physicians have an increased risk of making a serious error in a patient during surgery. They have 170% increased risk of having a motor vehicle crash driving home from work. So there are many adverse effects of insufficient sleep and extended work hours.
For those who cannot escape shift work, an otherwise healthy lifestyle can help improve their quality of sleep. Nutrition, for example, plays an essential role in stabilizing our sleep-wake rhythm. Eve Van Koude is an endocrinologist and metabolism specialist. She's headed a vast study on the links between sleep disorders and obesity.
When you start analyzing hormonal data over the 24-hour cycle, you recognize that there are some events that have a major impact. And the one event that has the biggest impact is sleep. We are the only mammalian species that sleep deprive itself, so it's a behavior that is completely abnormal and artificial. We started inquiring about whether this behavior could actually be involved in the epidemic of obesity, which affects all industrialized countries on every continent.
Two hormones regulate our appetite. Leptin decreases appetite, while ghrelin increases it.
That was just amazing, that these two molecules measuring the blood were able to predict how much more an individual would be hungry due to that sleep restriction.
We know from previous studies that sleep restriction is associated with an increased intake of high carbohydrate and high fat foods. So one of the questions I have is what is involved in this increased drive for highly palatable foods?
When there's not enough sleep, everything goes wrong. So leptin goes wrong, and ghrelin goes wrong, and endocannabinoid is dysregulated, and there's not a single system that is not affected by the lack of sleep. So our study addresses that issue of how dietary intake can help synchronize or desynchronize the peripheral organs that are sensitive to dietary intake, which is many, many of them, from the brain clock.
Claudia is slightly overweight. She's agreed to take part in Eve Koude's study. She'll spend 1 week at home, then another week at the hospital's lab. The goal is to better regulate her meals, to allow the brain to rest at night and help her sleep better. Eating too often keeps the body awake, which upsets the essential fasting phase during the night.
So we have you sleep in the lab around the same times that you sleep at home. We'd ask you to wear this watch the whole time. You will press this button on the side when you wake up and when you go to bed. Okay. And then we have something called the constant glucose monitor. You ready? 1, 2, 3. There it is. That's it. So every night we're going to wand the sensor, and we'll be able to see what you ate, when you've eaten across the day, and what your glucose levels were. Okay?
That's awesome.
Dark, sleep, fast. These three things have to be aligned for our biological clock to be able to control temporal organization in all the organs. The clock in the brain is synchronized by the light-dark cycle, but the clock in the liver doesn't see the light. So what is synchronizing the clock in the liver, in the pancreas, in muscle, and so on, is caloric intake.
The experiment is being carried out on several subjects under different conditions. As Claudia settles into her room, Eve van Koude and Aaron Hanlon analyzed the results of one of their first participants who arrived a week earlier.
So this subject was their first subject, and he was randomized to the extended overnight fast. And his biggest meal always in the evening.
Okay.
And fairly late, starting at 8. For an American, that's late. And day after day, this is the mean of 5 days. You cannot see where the overnight fast is. It looks like his glucose levels are all over the place across the 24-hour cycle. And then you can see that he is definitely pre-diabetes.
Yeah.
The lower curve is our intervention, and there we can really see that we change the glucose levels to a clear, low overnight fast, breakfast, lunch, dinner. So I'm really excited.
As a result, the patient's quality of sleep has also improved markedly.
The brain is a glucose guzzler. It needs glucose, it's its main fuel, and it uses more glucose than any other organ. As soon as you fall asleep, your brain is not using as much. So the metabolism is slowed down drastically. So what happens when you eat very late, instead of having the glucose go down in 3 hours, it takes 5 hours, 6 hours. So most of the night, now you have high glucose levels. The signal to the brain is that we are awake. Sleeping over high glucose levels is going to deteriorate sleep quality.
This study points to a terrible vicious cycle. The more often we eat at the wrong times, the less we sleep, and the less we sleep, the hungrier we become. How can our brains rest if our food intake is so frequent and so heavy that it simulates us being permanently awake? Clearly, our bodies have been unable to adapt to our modern-day lifestyle. Too many changes in the space of just a century deeply affected our circadian rhythm. Similarly, our bodies have not been able to grow accustomed to the increasingly sedentary nature of our lives. At the University of Caen, Professor Damien Daven conducts research on biological rhythms. He's looking to determine the impact of physical activity on the quality of nighttime sleep.
The Homo sapiens are designed to move, to exert themselves. Up until the 20th century, burning 3,000 to 4,000 calories a day was nothing unusual. This high energy turnover was enough to keep people in good health. We want to see if isolated physical activity at a specific time during the day has immediate consequences that night. Physical activity triggers the secretion of waking hormones, which need to be eliminated in order to sleep well. And the more intensive the physical activity, A squash match, for example, that's very demanding and requires a lot of energy. The harder it is to sleep afterwards. Before we can get a good night's sleep, we need to release pressure and return our temperatures to normal. We started asking ourselves what type of physical activity could improve sleep, and we concluded that it was aerobic exercise.
Aerobic exercise is a form of endurance training. While performing it, muscles draw oxygen from cells, unlike during quicker, more high-intensity exercises. Once the physical activity is done, Professor Daven analyzes the subject's sleep.
We're looking to see if his sleep is more intense, his deep sleep in particular. Right now, he's still awake, with considerable muscular activity, but he's falling asleep quite quickly. These are what we call spindles. They occur as we fall asleep. The optimal time for physical activity is in the late afternoon. Then, its effect on our sleep is ideal.
Endurance sports carried out in the late afternoon help realign our internal clock, making it much easier to fall asleep at night and improving the quality of deep sleep. These days, the combination of abundant artificial light, a poor diet, and the lack of exercise are the root causes of sleeplessness. Other factors, in particular stress and anxiety, also play a role. 1/3 of France's population regularly have trouble sleeping. 6 million combat their insomnia with medication.
I've been an insomniac since I was 20. I know it started before then, but that was when I started taking sleeping pills. Happy to see me? You were all alone, weren't you? Come on, let's go for a walk. I know that in order to sleep well, I should be in a completely dark room and only go to bed once I'm ready to fall asleep. But I start watching TV right after dinner, and I don't watch in the living room. I go to my bedroom and take my computer and my phone with me. I know these aren't the best conditions for me to fall asleep, but I can't help myself. These are the moments I savor. My dream would be to give up the pills.
Worldwide, 600 million people suffer from poor sleep. 1 in 5 Americans admits to having taken sleeping pills. In Europe, Spain holds the record, just ahead of France, where 131 million packets of sleeping pills are sold each year. Trouble falling asleep, jolting awake in the middle of the night, stress, anxiety, insomnia has a number of causes and effects.
Insomnia is defined by strict criteria. Trouble sleeping at least 3 times a week over a period of at least 3 months, with the consequences severe enough to have an impact the following day. Tell me a bit about your trouble sleeping.
If I don't take pills, I don't sleep. I lie awake all night.
Okay. And what's your goal?
I'd like to do without sleeping pills entirely. Getting myself off them would be wonderful.
So what we're going to do is record your sleep cycle to try to understand exactly what happens when you fall asleep and while you're sleeping. Then we can assess, bit by bit, how to help you sleep without or using far fewer sleeping pills. Ready for your polysomnography?
Yes. See you later.
I'll take you to the sleep lab.
This will register your eye movements while you sleep. Depending on the stage of sleep you're in, your eyes move in different ways. This device will record your sleep, and tomorrow morning we'll download the data.
A number of sleep cycles occur in one night. One complete cycle lasts about 90 minutes and contains 4 stages: falling asleep, light sleep, deep sleep, and the REM phase of rapid eye movement, during which we dream. This cycle is repeated 4 to 7 times in the course of a normal night. So it's very important to go to bed when you're tired.
The test showed you have great difficulties falling asleep. It took you nearly 45 minutes. And then you woke up frequently during the first part of the night.
That can't be normal.
No, it's not. It means your sleep is easily disrupted and fragile. This here is the spectral analysis we use to measure your brain waves while you sleep. Here we see very rapid waves, almost as fast as at the start of the night. They show that the brain hasn't completely settled down. In your deep sleep cycle, the waves become much longer and more restorative. But unfortunately, there's not enough of them. That's quite typical for insomniacs.
So I have trouble falling asleep, and when I finally do, I'm still awake.
Yes. While you sleep, you keep having periods of wakefulness, which get longer and longer as the night goes on. It seems that, at least this night, the medication wasn't effective enough. As the name suggests, a sleeping pill is a drug that induces sleep. But that's not true. It's not really sleep, but a light narcosis. The patient is half dozing.
The most common sleeping aids are benzodiazepines, from the family of drugs used as minor tranquilizers. They have sedative, hypnotic, and amnestic properties. They numb the entire brain, inhibit memory, and are extremely addictive. Theoretically, sleeping pills should only be prescribed for 4 weeks, sedatives for 12 weeks maximum. Yet the reality is quite different.
When benzodiazepine was first discovered, people were thrilled. While I was studying, we were told to prescribe as much as we wanted for however long we wanted. It took decades before we learned about its long-term chronic toxicity. And that's the problem. It's not toxic right away, only when you take it over a long period of time.
Sleep disorders affect people of all ages, but it's the older generations who suffer the most and seek medical help most frequently. In Lyon, psychiatrist Patrick Lemoine heads group therapy sessions for the French Association for Insomnia.
France is the country with the second highest consumption of sleeping pills in Europe. Nothing's worse than a symptom-centric therapy. You're in pain? Take a painkiller. Can't sleep? Take a sleeping pill. You're anxious? Use a sedative. We should be treating the cause.
I wake up at night and wander around. I can't sleep at all.
My insomnia manifests itself in nightly waking states I just can't get a handle on. When I was young, I slept normally. Then I had my 4th child who suffers from Down syndrome. They're 53 now, but I'm still constantly worried.
Insomnia is always caused by a sense of insecurity. Why does this person feel unsafe? Why is she afraid to sleep? What has kept her vigilant all these years? That's what we need to understand. Could illness or anguish be causing it?
I know when my trouble sleeping started.
When was that?
We can talk about that here? I was very ill. I didn't think I could talk about that here.
Wouldn't illness be a good reason to feel uncertain?
Well, yes.
The most common cause of sleep disorders is depression, and treating depression with sleeping pills just worsens the depression.
At the sleep center of his hospital in Paris, Professor Léger prescribes Natalie 2 different kinds of treatment. She'll start with mindfulness exercises, which should help with the drug withdrawal.
Our goal is for you to get a better sense of your current feelings, thoughts, and experiences, so you struggle against them less.
I understand.
Then let's stand up. Keep your eyes open and slowly raise your arm. Can you feel the position of your arm?
Yes.
Now lower it and raise the other arm. Do you feel it? Now lower it, and this time try raising your arm only in your imagination.
Okay.
Retrace this posture with your eyes closed. Can you feel your arm moving, even though you're not really lifting it?
A bit, yes.
You're using your sensory imagination. You're imagining a movement of your body.
Mindfulness meditation involves focusing on the present without letting other thoughts distract you.
I recommend you keep practicing. This training helps us work on ourselves. It helps us to accept our thoughts and feelings, which in your case will lead to a better night's sleep.
Professor Léger also prescribes light therapy. These sessions primarily use blue light because this color amplifies the positive effects of natural light and increases alertness during the daytime. Phototherapy also regulates the biological clock and helps combat depression.
The principle of phototherapy is to help to resynchronize your biological clock, your wake-sleep rhythm. You can start pedaling.
If I'd known, I'd have worn trainers.
Not to worry, you can bring them next time. Pedal at your own rhythm. That's it. It isn't a marathon or the Tour de France. Look at the wall. Look at the blue light. This is an alternative to medication. Enjoy your session.
Thanks. See you later.
During the day, exposure to natural light combined with physical exercise improves the quality of our nights. So our daytime activity clearly influences how we sleep.
I believe there are just 2 clinics in France with resynchronization rooms like this. One in Strasbourg, and this here in Paris. While this treatment isn't covered by public health insurance, it's very effective for a whole range of patients.
Poor sleep can even be a risk factor for Alzheimer's disease, as Professor Maiken Nedergaard has discovered.
The brain is so stressed out during normal wake time that it cannot do its normal housekeeping. And we speculated that this might be the biological foundation for sleep. The purpose of sleep is to clean the brain for all the waste product that build up during wakefulness. Nobody had really looked in the brain on how do the brain get rid of waste product. So we were starting to wonder, would glial cell be involved in that?
Glial cells nourish our neurons, supplying them with oxygen and nutrients. However, thanks to Maiken Nedergaard's discoveries, we now know another major purpose these cells serve. In the brain, the arteries are surrounded by space in which cerebrospinal fluid circulates freely. When we fall into a deep sleep, Glial cells open canals which release this fluid. It washes over the neurons, clearing away the waste that's collected there during our waking hours. So these cells are key to brain cleansing.
And once it's transported out of the brain here, it's dumped back into the blood circulation, and you can regard the liver as our professional recycling plant.
Doug Kelly is an engineer specializing in fluid mechanics. He's constructed the first model which shows how this cleansing system operates in the brain of a sleeping mammal.
Here's the middle cerebral artery at the surface of the brain of a live mouse. Okay. And blood is flowing through it, but of course our interest is the cerebrospinal fluid that's flowing through the spaces around it.
So this is really what's happening when we are asleep, that we have all these many milliliters of fluid running through our brain to clean it. This flow is much more efficient when we're in deep sleep. If you're in lighter stages of sleep or if you're awake, it does not work. So the deeper you sleep, the longer you sleep, the better you clean the brain.
Maiken Nedergaard has discovered that the waste being washed away is an amyloid beta protein. Its accumulation is directly associated with the development of Alzheimer's, a disease which already affects some 50 million people worldwide. And that number keeps growing.
Once we get elderly and sleep less well, clearly we start to accumulate some of these waste products. And those waste products is viewed by the brain's immune system as foreign object because they're not supposed to be there. And the brain will start an immune response to remove it. And that immune response on long term is actually very damaging for the nerve cells. You have an increased risk of developing Alzheimer's if you don't sleep. The medical industry spent billions of dollars trying to block the production of beta amyloid, hoping that that would cure Alzheimer's disease. It didn't work at all, simply because it is not a production problem, it's a clearance problem.
These discoveries could lead to new and far more effective treatments for Alzheimer's and sleep disorders. But in the race for new remedies, alternative treatments are also being studied. Inspired by meditation and yoga, this Paris-based company has reinvented the concept of cardiac coherence.
All of these methods have one thing in common: slow breathing and concentrating on an external point. We wanted to concentrate the best of all approaches into one simple product that's accessible to everyone.
François, ce ne sont pas mauvais conseils.
We wanted to develop a simple device. Today, there's a lot of talk of high-tech, connected products. But we wanted a disconnected product. To fall asleep, you must be offline. To turn it on, you simply swipe it with your finger, and it projects a circle of light on the ceiling. Now, we synchronize our breathing with the light. When the pool of light grows larger, we breathe in. When it shrinks, we breathe out. And we do that for as long as possible. The exercise lasts 8 minutes.
By slowing down their breathing, this little device helps patients relax. It's now recommended by many doctors.
We didn't really invent anything new. People have been talking about cardiac coherence for years. Even skippers use it. Anyone sailing solo can only take micronaps and must learn how to fall asleep quickly.
Naps are actually an important key to better rest. At the Sleep and Cognition Lab at the University of California, Irvine, they're studying this tried-and-true method. Sarah Mednick is a professor of psychology here. She uses neuroscience research to demonstrate the central role naps can play in sleep management.
The purpose of the research that we're doing at UC Irvine is to understand what are the basic mechanisms of sleep that support cognitive function, including emotion regulation, memory, creativity, alertness. We look at what is the brain activity using electroencephalography, EEG, to look at specific sleep features that occur during that sleep period, either a nap or a nighttime sleep, and see how did those sleep features relate to the improvement in performance that we see before and after the sleep.
Mop. Pumpkin. Hanger. Dog. Mouse.
Okay, now we'll set you to sleep.
Great.
Time for nap.
So a nap, we would say, is anything from, say, 5 minutes to about 3 hours. The ideal nap time is usually about 6 hours after you've woken up. If you nap earlier than that period, you're going to have a nap that has more rapid eye movement sleep, REM sleep. If you nap later, you're going to have a nap that has more slow wave sleep. These are two very important sleep cycles, and they contribute to very different types of performance improvement. So it really also depends on how you want to tailor your nap to suit the goals of your sleep. If you wanted to have more sort of study help in terms of learning your history lesson, maybe you want to sleep with more slow wave sleep and you don't really need REM sleep. Versus if you're somebody who has to come up with some creative ideas that will require REM sleep.
Let me know if I pull it all, okay?
If you wanted to just have a quick alertness reset button booster, then you would just have these short power naps, these 30-minute naps, and you could do that any time during the day.
Finding sleep is about finding a healthy lifestyle. Sleeping and eating at regular times, getting enough exercise, and of course, avoiding screens and blue light in the evenings as much as possible. By respecting sleep and our circadian rhythms, we can strengthen our memory and put fatigue and stress to bed.